All right, we've got 15 minutes left. Let's use technology. Start with the calculator. So with the TI graphing calculator, start off by going to the stat menu. And the first thing you want to do is the edit menu. Got a bunch of different columns for different lists. L1 can correspond to the X values, L2 can correspond to the Y values. The natural thing to do, go back to our data set here. Plug in the X values, 1, 2, 3, 4. L2 is going to be the corresponding Y values, 2, 4, 5, 7. Let's go ahead and make a plot first. You can make a scatter plot of just the data. You can also put the regression line in there, but I'm not going to do that right away. Notice on a TI-84 at least that my stat plot menu seems to be above my Y equals, but I got to use my second function. Second function, stat plot, gives me a menu that looks like this, and all these plots are turned off, so I have to turn them on. Plot 1 by default has L1 and L2, you can see as the lists that are used. If I enter this and switch it to on, make sure the lists are correct, L1 and L2. And the type is going to be the first option there. That's going to be a scatter plot. That's good. I should pick a good window for one thing. Now I'm in the window menu. Maybe like that. Okay, now I just hit graph and there they are. There's the 4 points. If you go back to the ordinary Y equals screen, if you already happen to know the regression line, you can plug it in. It was 0.5 plus 1.6x. Of course, by the commutative property for addition, you can also write that as 1.6x plus 0.5. You all know that. Hit graph again, you'll see the regression line. Looks like maybe it's going through that point, but we know it's not. The residual was non-zero. It's going to be a very rare thing for a regression line to ever go through any data point, even if you got hundreds of data points. It would be very, very unlikely for your regression line to go through any data points exactly, but it theoretically can happen. What about if you didn't know what the regression line was? If you go back to the stat menu and calculate, you can compute it, linreg. My calculator is set up to compute something else when I do this. There's A, that's the slope, B is the intercept. You got to look at the equation to know which one is which. Notation is not consistent with B0 and B1. What are these two other things? Maybe your calculator shows them, maybe it doesn't. If it doesn't, can you make them show up? Well, what are they, first of all? R is called the correlation. As a descriptive statistic, we talked about correlation in prob and stats more than this class in chapter 5 as a theoretical idea related to covariance. This is related to the theoretical correlation for random variables. It's not the exact same thing. This is a correlation of data. R squared is the squared correlation. Does that have a name? It actually does. It's called the coefficient of determination. We'll see that R squared, excuse me, R squared in a sense is a better measure of the strength of a linear relationship. And that's why it's shown. But if your calculator doesn't show make it show up, you should be able to fix that by going to the catalog button. It's above 0 on mine. And going down to the D's, I can go alpha D, I think, to go down to the D's, or the alpha already pressed there. Okay. To the D's, and look for diagnostic on, and enter that, and it'll say done, hopefully. And then when you go back to linreg, it should show the correlation and R and R squared as well. Why you have to do that, I don't know. It's like, why not just make that the default? I don't get it. But hopefully that works. Let's move on to a spreadsheet. Let's just do the quickest way of getting the regression line. Oops, without formulas. Of course, you can program the spreadsheet to do the formulas that we've used. I won't bother with that today, though maybe we'll look at it on Thursday with bigger data sets, and we'll also get some intuition about things. But if you're just after the answer as quick as you can, at least in Google Sheets, I think I like Google Sheets for making graphs better than I like Excel, generally speaking, especially for histograms. You can highlight the data. I included the X and the Y in there. And go to Insert Chart. It did pick a scatter chart by default, which is good. And we can customize it. Under customization, under series, you may want to write this down. In Google Sheets, at least, if you go down under series, you can add the trend line, which does mean the regression line. You can show R squared, the 0.98, and use equation for the label. And there we have it. Y equals 1.6x plus 0.5. The R squared looks like it's part of the equation, but it's not. With Mathematica, you can certainly plug in the data like this as a list of lists, a list of points, 1, 2, 2, 4, 3, 5, 4, 7, like that. That's the quickest thing to do. You could also do X data, 1, 2, 3, 4, Y data, 2, 4, 5, 7, and then you could combine those and transpose the resulting matrix like this. Will give you the same thing that I typed into data. And then you can just do fit data, comma. We want a linear fit, so we use coefficients, so to speak. Well, a constant term, you might call it, and an X term, and emphasize the variables X. And there we have it, 0.5 plus 1.6X. Is the quickest way to get the answer. And what about R? So I hope you downloaded R. It would be good, if you haven't done so, to start watching the video that I suggested. I will be referring to things in the video. I forgot the guy's name who's in the video. It's his data sets, I think. But today we're just going to use RStudio. RStudio is an interface that makes working with R simpler, so you should also make sure you download RStudio. So we have what's called an R script file, which is just a text file where you do your basic coding. The output tends to come down here in the console, though some output like plots come over here and the variables are kept track of over here. If I want to put the X data in there, I could do something like this. You evidently have to use a C for concatenate, which essentially I think merges the numbers. So you can do C 1, 2, 3, 4. To enter that on a Mac, at least, you have to do a control return. I'm not sure how it works on a PC. So I'm about to do control return. And we should see output down there. Yep. Okay, so that's been stored. And if you want to confirm X is a numerical quantity or vector, you might call it, with entries 1, 2, 3, and 4. And then I can do something similar for Y. C stands for concatenate, which is just, again, combining the numbers. 2, 4, 5, 7. Control return to enter that. And with Mathematica, it's shift return, and with R, it's control return. And then if you want to do linear regression right away, it's LM, which stands for linear model, parentheses, Y, and then tilde X. And then do control return. And there you see in the console down here, the intercept is 0.5 and the slope is 1.6. Okay, so that would be the quickest way to do what we were doing, to find the slope and the intercept. And again, entering these things up here in the script file is control return on a Mac, maybe control return on a PC too. It's not command return. You'll have to either experiment or look it up to see what to do. But again, your output's down here for the numbers. Graphs can be made over here. You see the variables up here in the global environment. You can do other things too. If I do, for example, summary X, that gives me, for example, the 5-number summary for the X data values, as well as the mean 2.5 down here. As an example, something else you can do. You can also make a histogram, although with so few data points, it doesn't really make sense to do so. And there you see a histogram of the X values. Hist does histogram. So those are a few basic things that you can do. Okay. As a little introduction to R, part of your assignment for Thursday will be to watch that video more, whether you've started or not. And we'll go into more depth. All right, we'll see you on Thursday.